I work for Internet Society, and basically I'm using up time for the coffee break, but bear with me anyway. What I want to talk today about is some real-life experiments, warnings, and also one useful tool that we built in a Go6 lab and also in IPv6lab.net from Sander. So, what is the problem statement? What kind of problem are we trying to solve? And please let me walk you through all the 6 degrees of my inner turbulence that is created when I'm thinking about this. IPv6 and IPv4 are fundamentally incompatible on the wire, right? They cannot talk to each other. So we need translation mechanisms. So one protocol could talk to another, especially because mobile operators are now deploying IPv6 on their networks. And for example, T-Mobile USA, they currently have 52 million devices on their network living just on IPv6, without IPv4, IPv6 only PDP context. What are they using? 464 XLAT, of course, because it's enabled by default in the Android application, in the Android stack. So 464 XLAT, of course, relies on NAT64 in the core side and DNS64. But we figured out throughout the years of testing that some people do weird stuff, really weird stuff on IPv6, especially in DNS. I will show you some examples later. So what are the important questions here? When you, for example, as a mobile operator, when you deploy IPv6 and use NAT64, do content providers know how their content has been seen from such environments? And the second question is, do connectivity providers know how their users' experience on IPv6 only would be? How would these people see content on the internet? The presumption is no problem, but is it? Okay, let's get this out of this project. First of all, projects like this this is massive amount of work and cannot be performed without the great support of the following organizations. Of course, Internet Society. I work for Internet Society. I would like to thank Internet Society for dedicating some of my work time to do these things in the lab, and giving us space for the lab. Sander Stefan and his company, he actually built the tool. He is a programmer. He actually built the tool that I will be talking about at the end. And Corinne Pritchard, Sander's best half, for a lovely design and the tool's front end. Hugs. I know she's watching now. Wave. Okay. So how did we start this? How did we even come to the idea that something might be wrong? Years ago, I set up a NAT64 test lab in Go6 lab. What is it? This is aimed for all operators, software vendors, operating system vendors, to actually test remotely how their things work over through NAT64. It is a very, very simple thing. I set up 4 different implementations of NAT64 in my lab, and actually I'm using the globally routable NAT64 prefix when the DNS64 is synthesizing the quad A records. So if you have IPv6 anywhere in the world, you just set your recursive DNS server to one of my DNS64 servers. It will start synthesizing the quad A records for you, and you will start sending packets back to Slovenia, where they will be translated and sent further to the internet. And then you can test how your application works, or how you will see the internet through NAT64. It's used by operators, it's used by application providers, it's used by hardware software vendors. I got an email from Android team once when they were testing 464 XLAT, and Lorenzo said, Jan, thank you for running these implementations remotely. We could test all 4 of them, found some bugs with one of them, fixed it, and now it works. It gained quite some traction. I see lots of traffic coming to all NAT64 implementations. So if you want to test how this all works, here is the URL. You can download this presentation. Here is the URL with instructions how to do it remotely. This is the screenshot of the instructions. You're welcome to use it. If you find something strange, please send me an email. My email will be at the end. All comments and suggestions are more than welcome. Yeah, you see, I have A10 networks, then Palo Alto Networks firewall. That's a big machine. You will not be able to overload it. Don't worry. YOL. This is it's a free tool. It's an open source implementation of NAT64, and also Cisco sent me an ASR 1K to the lab to run NAT64. So that box is somewhere. This is the picture of my lab. It's 3 racks of equipment. Sander calls it the systematic chaos, as it is. And these are the machines running the NAT64 implementations that you will be sending packets to if you want to test. All right. So while having these NAT64 implementations and people were testing it, I occasionally look in the log files how things are going. And I started to notice that not all things are going well. So what was happening? There were strange DNS requests and strange DNS responses. So have you ever seen these values in quad A records? For example, column or column 1, that's local loopback. Who sane in this world would put column 1 as a quad A record in DNS? I have no idea, but people is doing this. We also saw column, FFF, column, and IPv4 address. This will also not work with NAT64, believe me. FA80, the local loopback, the link local addresses, then we see 64 FF9B, that's a well-known NAT64 prefix, and then also the copy-paste people that copy-paste from the documentation prefix 2001 DB8 and some value. Do not put these things in quad A record, please, because things will break severely, especially through NAT64. There will be millions and millions of people that are on IPv6 only today that will not be able to see your content. So there is more stats on this link, courtesy by Dan Wink. He's doing a great stuff, analyzing top 1 million domains and seeing what kind of stupid things people put in. So then I was thinking further. So for example, this causes lots of confusion with or without www. If you ask for firstinsight.com, www.firstinsight.com, you get the address, and then when you ask for First Insight without www, you see that this one has the address of column. Well done. Nobody will be able to see your content ever. So what can we do about it? And I said, I was torn. I was on the fence. Should we fix it? Or should we avoid it? Should we mask the problem? What should we do? Remember, in this case, if you're not part of the solution, you're part of a problem. And this people is part of a problem. But at the same time, if you're an operator, you need to protect your user's experience. You cannot go and say, here is your mobile phone, here is your IPv6 only connection that you don't even realize that you are on IPv6 only, and then things stop working. It's not acceptable. I spent 20 years in operations, and I learned that this is not an acceptable approach. So we found out that there are exclude rules in DNS64 configurations. So we said, okay, if people is putting strange stuff into quad A, how can we exclude them? How can we filter them out? And basically, IANA allocated 2000/3 as the global unicast address pool. So whatever outside this finds its way into the quad A record, it's probably an error. So what we did, this is the bind 9 example of DNS64 configuration. Those who know me in the audience knows that there is no presentation, my presentation, that does not have the configuration code in it. So here we go. This is the configuration code. Here in bind 9 example, what we put in was that this is the DNS64 prefix, a NAT64 prefix, and exclude 0:/3, that is from 0 to 2000, then it's 400/2, 800/1, and also the documentation prefix. This means if the DNS64 server gets a quad A record from the original DNS server that has quad A record with anything outside this range of 2000/3, ignore it and create the synthesized quad A record with the NAT64 prefix. It's very simple. Of course, we also have to say break DNSSEC to yes, and I will explain it later. So let's go through this, a little bit of a moment of betrayal. Why should we break DNSSEC? I'm a great proponent of DNSSEC. Everybody should deploy DNSSEC. But with NAT64, we have a slight problem. With DNS64 and NAT64, you are synthesizing the quad A record out of the A record. And there is no way, no legal way, that you would have the private key of that domain to sign those quad A synthesized records, because they were created on the fly. Everybody in the world can create for you a quad A record if you don't have IPv6 on your content. So you need to put in the break DNSSEC yes into the DNS64 configuration. Otherwise, whoever has the DNSSEC signed zone, your DNS64 server will not return any results. There is a longer explanation how this works. But here is an example. You see, I asked dig quad A 4.go6.si back in my DNS64. It was nothing. Nothing was returned. There was no value. Then I put break DNSSEC yes in my DNS64 configuration, and all of a sudden I got the synthesized quad A record. This is the NAT64 prefix in the lab, one of them, and this is the IPv4 address in hex. So this needs to be in. For the unbound, of course, the syntax is a little bit different, and you basically say private address, and you put in these private addresses. At first, I tried to catch all the anomalies and the stupid things that came to my DNS servers, but then I just decided to exclude everything outside the global pool. Okay, here is more reading on DNS64 and DNSSEC. There is the whole RFC written on this if you want to know more. So let's go to more examples. Oops, firewalls.com. Still waiting for the timeout. There on the other side, it should be the NAT64 results. Still waiting for the timeout. Indeed, it's very secure. Of course, it's running on column, FFF, column, and IPv4 address. This will not work. This will not work on NAT64. Okay, we have good DNS, bad server. Spanish people. As you see, that On IPv4, it works. IPv6 and NAT64, it doesn't work because it doesn't work. Then we have good DNS, bad geolocation. That's our Slovenian sort of like a file cloud server. And it says on can use this service. Dude, I am in Slovenia. I'm sitting in Slovenia. What's wrong with you? But despite my grunging, it still said, no, you cannot use it. No quad A, but server still confused. You said uc.cn. You see, this is the Apache default setup. I have no idea what they did, but it didn't work properly. Okay, German people. On IPv4 and NAT64, it works fine. On IPv6, there are pictures missing. They are storing pictures on some IPv4 only server that has literals in it. People will not be able to buy your stuff if you don't show pictures, right? Fix it. The gateway pounded. Good server, bad content, of course, completely misconfigured. So these are things that you encounter while you go into some more rigorous testing. Okay, then if you have a not working quad A record, this means broken NAT64. There is nothing that can save you from that. And this is already the screenshot from our tool. If you have a quad A record and if your machine is reachable, but web server is not running on that machine, you're not helping yourself. You're not making it any better. Then IPv6 will fail and NAT64 will fail. Then we have working quad A record and IPv4 only content. So you see, this is what happens. See, if you press this resources match, the triangle, you will see all the elements that loads on this side. So this is not working properly. You see here, if you press this down, you will see all the elements, and you can directly compare with NAT64, IPv6, and IPv4 only, and you will clearly see what went wrong when loading this thing. So test all this. How to go and test? There are many things that we need to test. Test on NAT64, test on IPv6 only. Did all resources load okay? Does it look good to the user? Do we see any path MTUD issues? And therefore, Sander and I decided that we need to build a tool. And this is NAT64 check. As you see, here is the URL. You can go and test your website. It's up and running. It's free. It's open. It's nat64check.go6lab.si. What can you do here? Here you can put in your URL, and this thing will go. I will explain it how it works under the bonnet later. This thing will go and check for your content from 3 different environments: IPv4 only, IPv6 only, IPv6 only plus NAT64. And here are the previous measurements. It's all exposed, nothing is hidden. If you go and put in your URL here, it will show here among the measurements. You can have some fun with that. Okay, so here you have filtering. If you want just to see IPv6 good or IPv6 bad or average or NAT64 good, bad, average, you can filter out the results. That's quite useful. Okay, so examples. netbk.co.jp. I will show you now how we do the image match. So if you do the mouse over here, this is the mirror how your content is seen from the internet. If you do the mouse over, you will see it will show you the difference. How your content is seen from NAT64 versus IPv4 only. You see? The difference? That is a difference. We don't fix brokenness. With this tool, we did not put in the exclude statement. So if you have broken code A, if you put some weird stuff in your code A, it will just not work. We did not mask the problem. We are masking the problem with the NAT64 implementations that you can test remotely, but we are not fixing the brokenness in this tool. Otherwise, it would not make any sense, because it will show it to you that everything is fine. And here are two instances of this tool running. One is in Go6 Lab, one is in IPv6lab.net. It's under in Netherlands. You can use whichever you want. They are both free, open, available. So let's see a little bit how this works under the bonnet. Let me give you some illumination theory. There are 4 servers: the management server and the web interface. This is what you see when you go to NAT64 check.go6lab.si. And then a server with only IPv4, server with only IPv6, and server with NAT64. Go6 Lab specific, all servers are on virtual machines on Proxmox 4.2 Linux containers. And IPv6 lab.net specific are all running on virtual machines on a VMware cluster. So two different technologies used. Please be advised that IPv6 is on MTU restricted VLAN. Why? Because we want to simulate also these users that are behind tunnels. And you would be surprised how many web servers fails when there are path MTU issues and restricted MTU VLANs. We're using Phantom.js as a command line browser. It keeps track of loaded and not loaded resources, and it makes a screenshot when the page has loaded, so we can show it in the tool. Then the system compares images with each other and checks for resources that could not be loaded. So some images and words. The master server, IPv4 only server, IPv6 only web client, and IPv6 only and NAT64. And it communicates to the internet and just requests whatever you wanted it to request. Take the time, please. This test, when you press the button, test, there is lots of things to do. It sends the request, the requests have to load, there are some things that maybe time out, some things cannot be loaded. Do not press the button again. Just press it once and wait. It will tell you everything. It will tell you that it's doing the ping test, the path MTU discovery test, everything. You will see something like this. When you start the measurement, it will go testing in progress. You just wait, lay back, have a popcorn, beer, whatever, and wait for the results. Wash, rinse, and repeat. Let's lift some shadow of a dream. Let's test your website, how you do it. Are you sure that all images, analytics scripts loads over IPv6? We see a lot of analytic stuff not loading, and then your page look weird, or scripts not loading. If you don't have IPv6 on your server, and I have no idea why you don't have IPv6 on your server, did you hardcode any IPv4 addresses in your code? In this case, NAT64 will completely fail. You might get away with it on 464 XLAT, but not in any other case. So if things fail, make sure you're persistent enough to find the issues. Fix the issues and test again. Fix the issues, test again. Repeat until your website is no longer broken, but be aware. If you're fixing a DNS configuration, it will take time before it propagates to around the world and to our DNS servers. So DNS propagation is slow. Make sure that you take enough time and fix your DNS properly. We found even more issues. For example, if you don't have properly working target domain, people will not see your content through NAT64. You may get away with it on IPv4, but you will not get away with it on NAT64. You see here, there are some issues with the SOA that is not a subsequent zone, invalid response, and things like this. If you don't run your DNS zone properly, things will fail. That's a warning. We are in constant motion. The code is freely available. It's open. It's open source. The whole tool is on GitHub. If you want to contribute, if you have ideas how to make it better, we already received lots of ideas, and we will work on improving the tool. Lots of people is using the tool right now. I'm staggered that lots of people every day does the measurements, and they are looking how their content look like. But yeah, if you are a programmer, if you know Phantom.js, and if you know Python, please join us in developing this tool further. And this is the end of my presentations. If you're a content provider, test how people see your content. If you're a mobile operator or network operator, test how your users will see the content. If both, all of the above. You might be surprised how your content is seen to these environments. So this is it for me. Are there any suggestions, comments, questions? Or people is falling asleep without coffee?
Well, I can assure you one thing, like the coffee is still there, and you'll get the coffee break. So
excellent.
You can still ask questions.
Any questions?
Cool, so things are moving in the right direction in the Middle East region. Probably by next MENOG, as we heard from Du, that things will start shaping up. And I think it's a good idea. If people are doing stuff in the lab, that's what we saw in the presentation from Marty, that people are doing some test in the lab. So it's a good tool to test in your lab. Let's see how it goes. And you know how to reach us, right?
Yeah.
Hisham.
Yeah, it's not a question, more of a comment. Thank you for the presentation, and thank you for the tool. I know for a fact, again, Hisham Ibrahim, sorry, I didn't introduce myself. Hisham Ibrahim, IPNCC. We work a lot with the operators here, especially the mobile operators, and this particular thing that you're talking about comes up a lot. So thank you for coming and doing the presentation. Thank you for creating the tool, because I know operators that we already directed to use this, and they're beginning to use this. So thank you, Jan, for this.
Not a problem.
Yeah, thank you so much. And just to add what Hisham said, by next MENOG, we can do a hands-on tutorial on this one. If you have a lab setup and you want to do something and you want to test something, probably we can do something more hands-on next time.
Absolutely. I see, I was looking for you.
Nishal, the official troublemaker.
It doesn't work? It does work. Good morning. Nishal Gobardhan, member of the community, I hope. I just have a question. Do you have a way to show results to the public from the tool? So if someone's running the tool, do you have a way to aggregate the results of that and make it published? And I'm thinking of something like SSL Lab, the SSL Labs test. You know what I'm talking about? Mm-hmm. I mean, obviously you can have people opt in to show the yay or the nay. And the reason I'm asking this is I'm curious as using it as a benchmark to understand the measure of success that has been achieved by people first not getting stuff right and then getting stuff right later. Thank you.
With SSL Labs, it's on a to-do list. We are looking into ways how we could also implement the certificate testing. So while you are testing the content in the website, you could also test if the certificates on both protocols are the same, are valid, and things like this. So we could include this in the test. For the results themselves, there is a list of measurements that people did on the first page, where you can go and see what other people did. Now, the analytics of the measurements can be a little bit tricky, the aggregated analytics of the measurements, because what I'm seeing in the tool is that people come and does the test, and then they go and fix things and then retest it, and then it's still broken, and then retest it, and then fix things, and then fix things, and then at the end it's done and fixed. But then if I go and make the analytics of all these events, it will not show the proper results, right? Because it would say it's half broken still. So we need to figure out how to track individual measurements through time, and then find some clever magic to make it work. Thank you.
Thank you so much. Thank you so much, Jan. And
thank you.